Yeah, yesterday we talked about a rate integral being position change or net change, right?
Right.
Okay, this is a subset of that. It's more contextual, it's more specific. Okay? Let's say you're given a rate function and you drive from Parachute and you go to Denver. Boo.
But Denver has the aquarium.
Yo, I have to drive to Denver.
You go from Parachute to Denver, and then you come back to Glenwood Springs.
Oh.
Oh, yeah, that's what we're doing. Distance travel.
Yeah, okay.
Yeah.
Okay. How far have you traveled? Because this is like 180 miles, and this is
45.
like 140 miles.
Is it? I'll say 45 miles. It's actually 200. If we're really trying to do that, it's 201. Ah, okay. Denver?
You know what?
No, to Denver, it's 180 miles. To the middle of Denver, it's probably 201.
All I know is you get like right off the exit, it's at 201.
Yeah, to Denver, downtown. Okay, anyways. Okay, what is our total distance?
320.
Yeah, how far have you actually driven? 320 miles, right? Okay, yeah, exactly.
The displacement is always
I don't know how far away is Glenwood from here?
40 miles,
No,
right?
it's 40.
40 miles.
Right. Here to here. This is displacement, right? Displacement versus distance traveled. Correct?
Correct.
Okay.
Yeah, Miss Doyle brings up the Wendy's theorem whenever we talk about it.
Wendy's theorem?
Yeah. Because
Whoa, 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 whoa. One at a time, please.
Okay.
Mackenzie.
So the Wendy's theorem is where the entire class goes over to Wendy's and then comes back, and then it's technically like we never left.
Yeah, displacement equals zero.
Yeah, you're
Never
just.
left.
But how far have you actually traveled?
I don't know, like a mile and a half.
A mile and a half.
Maybe 2. Maybe a mile.
2.2 miles.
What? To Wendy's from here? Isn't it a mile to the bridge?
It's 1.1 miles to the stoplight. Don't ask why I know that.
Why do you know that?
really tempted to ask.
I said don't ask.
That's when you feel good.
That's why you say don't ask.
All right. When you're given a rate function,
I had a baby carrot.
in our case, a rate function is going to be a velocity function.
Yeah.
If our velocity is positive this direction, it has to be negative this direction, correct?
Right.
Okay, so when we calculate these, we have to account for that. Okay. So, a displacement integral
Don't we already do that though? Because we subtract if it's negative?
a displacement integral is automatically going to do the math for you. Because it's going to add the velocity positive and then subtract the negative. It's automatically going to take care of that for you. Okay? So this is a displacement integral.
That's what we've been doing, right?
Yeah, we've done these.
What's that?
R of t.
Oh, was that like that last one that we just did?
Displacement. Right, that's why I put it here.
Was that just like that one problem that we just did in the homework? Where it's R2? 0.65, the one with the megawatts?
Oh, yeah, it's just your rate function. You could put v of t if you want. Okay, so displacement is automatically going to calculate here. If you do the integral of that function.
I said Wyoming.
Okay. How do I deal with the negative in distance traveled? Okay. Okay, so to figure out distance traveled, I need that to be positive. This needs to be positive as well.
Absolute value.
Okay, that right there. That's one way to do it. Okay, so. Okay, Connor, we're going to come back to your thought here in a second. Okay, so distance traveled is the absolute value of the function. Okay? It turns everything positive and we add. Okay? So that means A to B. Right?
Would that be when we evaluate, instead of subtracting B minus A, we just do B plus A? Yes.
Close, I think. Okay. How do I do this algebraically? Because you don't know how to integrate an absolute value.
Separate them.
Yeah. What do you separate them into?
Negative RT dt and positive.
A to what?
B.
Negative B.
A to C.
Oh, A to C.
Oh,
And then
Is regular, right?
And then C to B.
And then C to
B.
B, because I labeled Glenn with B. Subtract or add?
Add. What?
Subtract, it's negative.
I know it. Track.
This integral spits out a negative, correct? Because it's negative velocity. So I have to subtract. Subtracting a negative makes a positive. Okay? So that's the only difference. So yeah. Algebraically, this is how you split the integral.
why can't we just add instead of subtracting and evaluate?
Because if you add, this gives you a negative value.
Like, so if you
It's going to
evaluate
subtract it.
the RT from A to B, instead of subtracting RB from R of A, you just add them. You get distance traveled. So RB
You
minus
could.
RA equal, or
No,
RB plus RA.
because that changes. Because you haven't considered where that exists. You haven't considered where C is. If you just do R of B plus R of A,
Yeah. Why does that matter?
it's because you don't know where this negative starts and ends. You have to consider where it starts and ends. You have to know where the velocity changes sign.
If you just add it, it won't matter.
Does matter. Uh-huh.
Trust me, it matters.
Alright.
It does.
Why do you put dt at the end of everything?
Because
Because it's 2t, derivative t.
No, it's
Derivative in relation to time, right?
Yes, that's true.
well, the first thing, it's like a period. It closes the integral off. Right? It says you're done. And the second thing it does is tells you the variable to integrate. Because if these are different,
So when there's like
Okay.
an R back, then we get like.
well, in your case, yeah, but there is calculus that does not do that. Okay, so that's why we have to define that. Okay. Good question, Jeff. Very good question. Okay, let's do a particle motion problem. A particle has velocity. Let's make that a cube. Oh, goodness. Okay, I'm just going to start over. T cubed minus 10t squared plus 24t meters per second. Again, particle motion problems, you can ask a dozen different questions. Here's one of them. Calculate displacement for this interval. Okay, what's the integral?
Integrate 0 to 6 t cubed minus 10t squared plus 25.
Does it need absolute value?
No.
No. Displacement does not. Okay. Okay, you can do that. I'm not going to run through it. It's just right. No, it doesn't. It doesn't take too much time. It just takes more time than we want to spend on it. Because we're running short. Okay. Are you okay with that?
Yeah.
Okay. Calculate what?
Distance.
Distance traveled. Same interval.
And it would work with the absolute values of G.
So, a question. So, Mr. Arthur, when like you would go to write this, would you initially put it in 0 to 6 in the whatchamacallit?
Absolute
value, and then put it into the A and C?
You don't have to write that.
Okay.
Absolute value. Either one works.
Oh.
Yeah, good question. Okay, that's distance traveled, right?
Yes.
Okay, the question is there a negative velocity? We need to figure that out.
I'll definitely figure it out.
So, can you only use the C if there's negative velocity? Or the separated ones?
Yeah, if there's no negative velocity, you just do the math, right?
Yeah, it doesn't state that there's one.
Displacement equals distance traveled in that case.
Okay.
But if there are negatives in this one, we just need to figure out where those are.
Wait, if there's no negatives, you're gonna have the same answer.
Yeah. Yep. Yeah, if there are no negatives, you have a starting point and an ending point.
Yeah.
But if you have negatives, they come back that direction. So. Okay. All right. So how do I calculate negative velocity?
Critical points.
Yep. So I need a derivative.
Oh, so we need the acceleration, so 3c squared minus 1t plus 24. Oh, this is true.
Okay. Can I factor something out there?
Yeah. No. This 3 doesn't go into 20.
Bummer. Can you factor that? Oh. Hold on a second. No, we don't need the derivative. What am I thinking?
Don't we need the anti-derivative?
No, neither.
What do we do?
I'm given a velocity function.
Oh, yeah.
How do I figure out where velocity is negative?
Critical
Set velocity equal to 0.
Oh.
Yeah, sorry. Whew. Where that came from. So velocity is 0, then we'll figure out a sign analysis, right? So factor a t out
That's not LG.
first. And then factor the quadratic. It's like t
Minus.
6,
Yeah.
t minus 4.
So 6 and 4.
And 0.
0,
And 0.
4, 6. Okay, what's the velocity at 1? Negative or positive?
Negative.
Positive. Way positive.
And velocity at 5 is going to be negative. So we have a negative from 4 to 6. That's what we were trying to figure out. Right. Okay. Are you with me on that? Finding where velocity is negative.
So then do the integral from 0 to 6, or 0 to 4, and then 4 to 6.
Minus 4 to 6.
So would
Okay,
you
are we good? Go ahead.
would you use 4 and 6 as your like B and C, or would you use
Yeah, so you're going to do
0 and 2?
0 to 4 minus 4 to 6.
Okay.
Question.
I didn't know because it like you didn't spot.
If you had multiple clips, would you do like 0 to 2, 2 to 4, 4 to 6?
Don't need to.
But can that happen?
Yeah.
Because that's the only time my thing doesn't work.
So,
It's gonna work.
If there's a time it doesn't work, you cannot generalize it and use it. Damon.
so do you do 0 to 4 because it has the same sign?
0 to 4 is positive.
So, right, so because it has
So
the same
just-
sign, you do 0 to 4, and then when the sign
And then
changes-
subtract the negative,
Okay.
right? Again,
So-
you can,
Anytime we have to do a distance travel, should we always check for negative velocity?
if you have to do a distance travel problem, you need to check for negatives. Okay. All right. Did I give you all the problems or just
Just yesterday.
5 through 13 odd? And then some AP 2s, AP 3s, and AP 4 Tuesday.
Tuesday, Monday.
Ah.
Oh, stop it.